Hi, good morning students. I am Vaishakhi Shah from LJ Institute of Engineering and Technology. In last lecture, if you remember, then we discussed flow through the pipes which are connected in series as well as parallel. Now in today's lecture, we are going to study some examples based on pipes connected in series and parallel. Okay. So here is our first example. A pipe system consists of two pipes arranged in series of length 200 meter and 300 meter and diameter 20 centimeter and 30 centimeter respectively. The difference of head between two reservoir water surface is 10 meter. The friction factor for two pipes are 0.02 and 0.015 respectively. Then determine the flow rate. This data is given in your example. So first of all, according to your data given, there are mainly two pipes given. First pipe of length 200 meter and second pipe of length 300 meter. Again, in this data, diameter of pipe given, diameter of first pipe is 20 centimeter and diameter of second pipe is 30 centimeter. So diameter of first pipe D1 equals to 20 centimeter and D2 equals to 30 centimeter. Okay, and from diameter you can also find the area. A1 equals to pi by 4 D1 square. Here D1 is 20 centimeter. So you can convert that centimeter into meter. So you get 0.2 meter. So A1, that is pi by 4 D1 square, pi by 4 0.2 square. So your area A1 is 0.0314 meter square. Okay. Now here also D2 is given, diameter of pipe 2. So you can also find out area of pipe 2, which is A2 equals to pi by 4 D2 square. Here D2 is 0.3 meter. Again we converted centimeter into meter. So you get A2 equals to 0.0706 meter square. This is value of A2. So you get A1 and A2 here. Okay. Now again in your example, length of pipe is given. L1 which is 200 meter and L2 which is 300 meter. Okay. Now difference of head between two reservoir are given, which is 10 meter. So here difference of water level is given. Difference between water level between two reservoir, between two container is given, which is 10 centimeter. So your value of H, which is 10 centimeter, sorry 10 meter. So capital H equals to 10 meter. Okay. Okay. Now in this data, the friction factor is given for both the pipes. Friction factor. Now we indicate friction factor F dash equals to 4F. Remember that we also studied this friction factor term in our Darcy-Weisbach equation also. Friction factor F dash equals to 4 into F. So in this data, friction factor is given to you. So friction factor for pipe 1. So 4F1 equals to 0.02. Friction factor for pipe 1 equals to 0.02 and friction factor for pipe 2 equals to 0.015. Here value of 4F1 and 4F2 is given. 4F1 or 4F2, which is called friction factor. Clear? Now here pipes are connected in series. In your first line of this example, it is given that two pipes are connected in series. So when both the pipes are connected in series, then you know that Q1 equals to Q2. Discharge of both pipes must be same. So Q1 equals to Q2. Now as we know that continuity equation. What is continuity equation? A1 V1 equals to A2 V2 equals to Q. So you can simply replace Q1 and Q2 by A1 V1 equals to A2 V2. Okay. Here we know the values of A1 and A2. So place the value of A1 and A2 in this equation. So you get that 0.0314 into V1 equals to 0.0706 into V2. So by making subject V2 as your subject, then you get V2 equals to 0.445 into V1. This is answer for V2 here. Clear? Now in this data we have to find out flow rate. So continue in this derivation. If there are two pipes are connected, two pipes, as you can see in this diagram, there are two reservoirs placed side by side. There are two reservoirs which are placed there. Okay. Now two pipes are connected. As you can see that the blue color lines indicate the pipelines. So two pipes are connected in series here. Okay. The difference of water level between these two reservoirs is your H. Difference of water level, that is your H, and here H equals to 10 meter, which is already given in your data. Okay. H1, that is from center to water level in reservoir number 1, and H2 water level in reservoir number 2 from center line to water level. Okay. Now two pipes which are indicated with blue color are connected in series here. So there are different type of head losses here. First of all, here first is loss of head at entrance. As you can see in this diagram, or it is indicated by arrow also, that when the fluid from the reservoir enter into the pipe, at that entrance there is a head loss which is called head loss at entrance. Okay. Now when fluid enters, it also goes into the pipe. So in the pipe which are indicated with this blue color, there is a loss of head due to friction. As you can see this arrow, here is a loss of head due to friction. Okay. Now fluid is again moving forward. There is a third head loss, which is head loss due to sudden enlargement. As you can see in this diagram, that orange line, the line indicated with orange color, that is at that point the water or the fluid suddenly expands. So at that there is a head loss due to sudden expansion. Okay. And now again when the fluid moving further, there is a last point which is indicated by this arrow or that blue line, when the fluid again exits from the pipe and goes to the reservoir number 2. So at that time there is a loss of head at exit. Loss of head at exit. So there are mainly 4 different type of head losses occur in this pipe connected in series. Okay. If we have to find out total head loss, then total head loss H equals to summation of all these head losses. So total head loss H equals to HI, head loss at entrance, plus HF1, head loss due to friction, plus HE, that is head loss due to sudden enlargement, plus HF2, that is again head loss due to friction in pipe number 2, and third is HO, which is head loss at outlet or head loss at exit. So here we have to find out the values of this all the head losses here. So first of all, total H equals to HI plus HF1 plus HE plus HF2 plus HO. Okay. Now we will find first of all HI, head loss at entrance, and as we know that head loss at entrance, the equation is 0.5 V1 square upon 2G. Okay. We do not have the value V1 here. So HI equals to 0.5 V1 square by 2G. Now HO, head loss at exit. HO, head loss due to sudden exit equation for that head loss is V2 square by 2G. V2 square by 2G. And by continuity equation, we found V2 equals to 0.445 V1 square by 2G. So, we are placing that value here. You get HO equals to 0.445 V1 square by 2G. Clear? Now, third head loss, which is HF1, head loss due to friction. And as we know that head loss due to friction, we can find by using Darcy's Weisbach equation. So, 4F1 L1 V1 square upon 2G D1. This is your Darcy-Weisbach equation. Now, placing the values in the equation, we already have 4F1, which is 0.02, L1, that is 200, and V1, we do not have the value of V1. So, V1 is your subject, and 2 divided by 2 G D, that is 0.2. So, you get HF1 equals to 20 V1 square upon 2G, 20 V1 square by 2G. Now, second is your head loss due to exit, head loss due to sudden expansion, and the equation for head loss due to sudden expansion is V1 minus V2 square divided by 2G. Okay, here V1 is unknown. So, V1 minus 0.445 V1 square, we have the value of V2, that is 0.445 V1. So, V1 minus 0.445 V1 square divided by 2 into G, divided by 2G. So, you get HE equals to 0.308 V1 square by 2G. Clear? Now, third is HF2, that is head loss due to friction in pipe number 2. And again the equation is 4F L2 V2 square divided by 2G D2. Okay. We also have the value of 4F2, which is 0.015 into L2, that is 300, into we have the value of V2 here, which is 0.445 into V1 square divided by 2 into G into 0.3. So, you get HF2 equals to 2.97 into V1 square divided by 2G. We have all the values of all head losses here. Okay. So, total head loss, you can take summation of all the values here. So, we have HI, HF1, HE, HF2 and HO. So, placing the values here, you get equation for H, and we have the value of H, which is 10, and this become 223.976 into V1 square divided by 2G. So, you get V1 equals to 2.86 meter per second. You get the value of V1 by solving this equation. Now, as we know that V2 equals to 0.445 V1. Now, placing the value of V1 in that equation, so you get V2 equals to 1.27 meter per second, 1.27 meter per second. Okay. Now, in this summation, in this example, we have to find out flow rate, which is your discharge, and you have the equation for discharge here, Q equals to A1 V1 or A2 V2. Now, we have all the values of A1 V1 or A2 V2, and placing the value in this equation, you get discharge Q equals to 0.089 meter cube per second, and that is your final answer for discharge or flow rate through the two pipes which are connected in series. Clear? So, your discharge is 0.089 meter cube per second. Okay. Now, our next example, a pipe system consists 3 pipes arranged in series as shown in figure. The transform the system to first an equivalent length of 30 centimeter diameter, and second an equivalent diameter for the pipe 6500 meter long. Okay. In this data, this diagram is already given to you. There are 3 pipes which are connected in series. Okay. First pipe, diameter of pipe number 1 is 0.4 meter, diameter of pipe 2 is 0.3 meter, and diameter of pipe 3 is 0.2 meter. Okay. Length of pipe 1 is 1000 meter, 1000 meter. Length of pipe 2 is 2500 meter, and length of pipe 3 is 3000 meter. These values are already given in your data. The diagram is already given to you. Now you have to find out an equivalent length of 30 centimeter diameter pipe and equivalent diameter for the pipe 6500 meter long. Okay. So by solving this example, first we have to find out an equivalent length of 30 centimeter diameter pipe. So equation, that is L by d raised to 5 equals to L1 upon d1 raised to 5 plus L2 upon d1 raised to 5 plus L3 upon d3 raised to 5. Now here d, that is your equivalent diameter, and we have to find out equivalent length. So here L is your unknown, L is your subject, and you have the values of all L1, L2, L3, D1, D2, D3, and here in data the diameter, equivalent length of diameter given, which is 30 centimeter. So your value of D is 0.3 meter. So placing all the value in this equation, you get L equals to 25518 meter. Here L is your equivalent length of all three pipes which are connected in series. Okay. Now in second case, we have to find out an equivalent diameter when length of pipe is 6500 meter long. So here L is given to you, which is 6500 meter, and you have to find out diameter. So your equation remains same, L upon d raised to 5 equals to L1 upon d1 raised to 5 plus L2 upon d2 raised to 5 plus L3 upon d3 raised to 5. Here we have all the values of L1, L2, L3 and d1, d2, d3. Now we have to find out diameter, which is d, and L is given, which is 6500 meter. So your subject become D, and you get, by solving this equation, you get D equals to 0.228 meter. Here D is your equivalent diameter of all the three pipes which are connected in series, and L is the equivalent length of three pipes when they are connected in series. Okay. So enough for today's lecture. Now in next session we will discuss some more theories and some more examples based on flow through the pipes. Okay. Thank you.